ಗೋಪಿ ಭಾಗ್ಯ ಮಧುವ್ರತ ಶೃಂಗಿ ಶೋಧದಿ ಚಂದಿಕಾ ಕಲಜೀವಿತ ಕಾದವ ಕಲಹಾರ ಚಂದ್ರಹ. What if I told you this is not just sloha but a hidden number? Today, let's uncover the connection between ancient number systems and modern scientific notation. Before the decimal number system was widely used, ancient Indians had already developed brilliant ways to represent numbers. Broadly, India used two systems. In the southern part, Bhuta Sankhya. In the northern part of India, Katapayadi system. Let's start with Bhuta Sankhya. This system converts numbers into words. For instance, 1 can be represented as one face or one mouth. 2 can be two eyes, two hands, or two legs. So, a single number can be represented using multiple words. Numbers were reused creatively. Next comes the Katapayadi system. In this system, letters are assigned numerical values. The Ka series, Ta, Pa, Ya series represent numbers. The word Yadi comes from Sanskrit Adi, which means etc. So, when you write a sentence, there are hidden numbers inside it. This is the same concept but written in poetic or sloha form. What's the advantage? Large numbers become easy to memorize. No digits are missed. The order stays perfectly accurate. This is exactly the idea behind a powerful modern concept, scientific notation. Before we understand scientific notation, we need to learn two important concepts: index notation and significant figures. These three belong to the same family. Let's start with index notation. In India and the UK, we call it index notation. In the US, it's called exponents. Here's the idea: 10 to the power of 2, 100. This means 10 multiplied by itself 2 times. So power 2 means 2 0 after 1. Now look at this: 10 to the power of 3, 1000. Instead of multiplying again and again, just look at the power. Write 3 zeros, put 1 in front. As the power increases, the number of 0 increases. That means we are multiplying by 10 again and again. Now let's go backwards from 10 to the power of 3 to 10 to the power of 2. Then 10 to the power of 1, 10 to the power of 0. Each step we subtract 1 from the power. Now look at this: 10 to the power of 0 is 1. Each step reduces the value by dividing by 0. The value by dividing by 10. So the number becomes smaller and shifts into decimals. So what happens after that? 10 to the power of negative 1. Negative power means dividing by 10 each step. 10 to the power of negative 1 means 1 over 10, and 1 over 10 is 0.1. Same like 10 to the power of negative 2. Negative 2 means 1 over 100 is 0.01. So negative power means we are dividing by 10 again and again. Now let's understand significant figures. In real life, we cannot always write exact large numbers. Take India's population. It keeps changing every second. But the first few digits are the most important. Instead of saying the full number, we say approximately 147 crores. But if we want a short and accurate form, we write 1.48. It's significant figures, which means accurate part. This helps us compare values easily. Now comes scientific notation. It's used to write very large numbers and very small numbers in a neat and clear way. For instance, take the mass of a proton. It is an extremely small number. Instead of writing many zeros, we write 1.673 into 10 to the power of negative 27. Negative power means very tiny number. Why do we write 1.673? Why not 16.73 or 167.3? Because in scientific notation, 1 less than equal to a less than 10. Only one digit is allowed before the decimal point. The first digit of the number is between 1 and 9. If you have 0 digits before the decimal, for instance zero point 0.6 into 10 to the power of 9, it's not scientific notation because zero point 0.6 less than 1. Or if you have 2 or more digits before the decimal, 10.6, it's not in scientific notation because 10.6 greater than 10. Now let's go to something huge. Imagine the number of protons in the sun. It is unimaginably large, not billion, not millions. So we write it as 1.19 into 10 to the power of 57. Positive power means huge numbers. So, why do we use scientific notation? It saves space, it avoids mistakes, it makes comparison easy. Now, remember the sloha we started with. That sloha follows the Katapayadi system. When you convert the words into numbers, you don't get a random number. You get a value of pi. The commonly used value is pi equal to 3.14, which means approximately pi equal to 3.14. But the real value goes on endlessly, 3.14159265. It goes on. Ancient scholars encoded this in sloha form so that it can be memorized perfectly without losing a single digit. So, whether it is ancient slohas or modern scientific notation, the goal is the same, to represent numbers accurately, clearly, and efficiently. Mathematics is not just calculation, it's a language of ideas, a bridge between past and the future. And sometimes a poem is also a number.